Hi, hello, this is Ravi Shankar Chinnam, myself working Java professional as well as Java online trainer. So now we're going to discuss about Java. This is our first session. Let's taste the cup of Java. So by the end of this session, we're trying to understand what is Java, why we go for Java, what are the differences between C and Java, why Java is better than C, what are the advantages and disadvantages of Java. So before starting the discussion about Java, let me ask you one question. What is a program? Yeah. So in your mind, you might be thinking that a program is a set of instructions. Yes, undoubtedly, it is a correct answer. So, but my question was one day, one fine morning, in your home when you're watching TV or watching a movie, whatever it may be, your mother came to you and she asked you about, hey dear, can you please tell me or please explain me what is a program? So to your mother, you might say that, mommy, a program is a set of instructions, right? Or you might elaborate and explain like a program is a set of instructions. It might have a lot of lines of code, right? Lot of lines of code. So your mother might be educated person or well-educated person or whatever it may be, so she might pretty much understand what is a program, and she might feel like happy that my son is great. So one fine day, another morning, what happened is your grandmother or grandfather came to you and they called you and they said, can you please explain me what is a program? So then can you say them that a program is a set of instructions or it will have a lot of lines of code? Yes, you can say, but will they understand? No, they can't understand, right? So then how can you explain them about a program? So if you explain them in any way, any kind of approach, any kind of manner, they can't understand because most of our grandparents are illiterates. They don't know about this programming or they don't know about the technology, right? So what I'm asking is a program, definition of a program should be understandable by any person in the world. So let's try to understand what is a program based on our example with a real-time scenario. Okay, so let's take an apartment, like an apartment which you are living currently. So this is your apartment which is having 5 floors, suppose, okay, per se. So in your apartment, you are living in your 5th floor, okay? Your apartment, your flat is in 5th floor. So how will you go to your flat daily? By taking the help of a lift, right? Directly from the ground floor to the 5th floor you are going. So one fine morning, what happened is the power has not there in your apartment. So at the time, what will happen is the same situation happened, like the power is not there, and one more thing is the generator is not there or inverter is not there, whatever it may be, there is no other opportunity other than staircase, right? So then what will you do? You will take the help of staircase, right? So what will you do? Like in order to go from 1st floor to 5th floor, first you will go to 1st floor from ground floor, and then 2nd floor, and then 3rd floor, and then 4th floor, and then 5th floor, right? So then here what you are doing is you are doing the work manually, right? So but when you take the help of a lift, you are not doing any kind of great work, right? The lift is doing everything for you. So in the same scenario, if you consider that example as a program, the lift is a program. That means a program is a one which reduces the human being's effort, right? Which reduces the human being's effort, or effort made by the human being can be reduced with the help of a program. In this scenario, a lift is a program. Or else if you take one more other scenario like a car or any motor bicycle or whatever it may be, you can take any kind of real-time example which can be seen by you and you can compare with that. So anything can be treated as a program which will reduce the human being's effort. Undoubtedly, a set of instructions or a lot of lines of code will have a program. It will treat like a program. It is also the correct definition, but according to me, I can redefine the definition of a program like a program is a one which reduces the human being's effort and which which is also having a set of lines of code as well as a lot of lines of code, whatever it may be. Okay, so now, who will run the program? The next question to you is, who will run the program, right? Undoubtedly the processor is the one which will run the program, right? By the instructions based on the program, the processor will perform some task and it will execute the program, right? So let's take one small and simple example and try to understand Java in a better way. Okay, so I think you're pretty much aware of C programming. Even if you don't know about any kind of programming, like even if you don't know any programming language, it's okay, fine for me to start Java. So what are my prerequisites was, you don't need to learn any language, or you don't need to have knowledge on any kind of programming language. Just if you have some kind of common sense is sufficient, or more than pretty much enough for me to start a course Java with me. Alright, so let's take an example. So consider an example called as Intel processor. We're going to take one Intel processor. Okay, this is an Intel processor which is having this is a system which is having Intel processor. So in that Intel system, like in this Intel processor system, what am I doing is I'm creating one C program, a very small, simple, silly C program that is nothing other than adding two numbers, right? Adding two numbers. So I'm renaming this as add.c. So immediately after, what will you do? We will give this program to compiler, right? C compiler. We will give this program to C compiler. Immediately, what the C compiler will do? The C compiler will compile the program and it will check the it will check the code and it will validate the code and it will give a .exe file, right? It is giving a .exe file, and one more thing is it will give a some kind of processor specific instructions. What it will give? It will give you processor specific instructions like I add 10, 20. Alright, I add 10, 20. So this I is specific to Intel, so like Intel specific instructions, right? So based on that, what the Intel processor will do is it will check the instruction and it will execute the program, and we can see the output 30, right? This is a typical or a very silly kind of small scenario which we can take with respect to C programming, right? So what I will do is, now I'll take one more system, but this time I'll take AMD processor, right? So I'm taking one AMD processor system. So I'm repeating the same scenario here. So I'm creating one new program again in AMD processor. I'm creating new program, okay? So I'm renaming it as add.c. Again I'm giving it to compiler. So I'm giving it to C compiler. So immediately what the C compiler will do? It will validate the code and it will generate .exe file, right, with processor specific instructions, right? So but this time we are using AMD processor. That's the reason why it will produce, or it will convert the .c file to .exe file with a at 10, 20, the processor specific instruction with respect to AMD processor. So now immediately when we try to execute this add.exe file, so what it will do is it will check whether the processor instructions is there inside that .exe file or not, and it will execute the program .exe file, and we can see the output 30 now. So the same scenario is working in AMD as well as Intel processor. So now I want to try a silly thing or simple, some kind of different approach I want to take, and I want to see some beautiful things. Okay, what I want to do is, let's take this .exe file, okay, this .exe file from Intel processor. Okay, see here I am taking Intel processor and I am taking the .exe file from AMD processor. Okay, this is the Intel processor system, and I am taking the .exe file, the same .exe file from AMD processor. Okay, but this .exe file is generated from the AMD processor. Okay, now what I want to do is I'll take this A at 10, 20 in Intel processor. Now when I try to execute, the processor will again check for processor specific instructions, right? So but this time we are not having processor specific instruction. This instructions are related to AMD processor specific instructions. So this time what will happen here is it will try to execute the program, but we can't see the output 30 because it is not related to Intel processor specific instructions, right? So now we'll take the other scenario, AMD processor. So in AMD processor, what I want to do is I want to take the other scenario, reverse scenario, like I'll take the .exe file that has been generated in Intel processor. Okay, the .exe file which is generated in Intel processor. So here now we are having processor specific instructions that is related to Intel processor. So now here what is happening is I add 10,20 is Intel's processor specific instructions. That's the reason why it can't execute and it can't show the output 30 again. Yes, it's true. If you want, you can try out with two different systems, not only Intel processor, not only AMD processor. You can take any kind of processors, like IBM processors is available in today's market. There are so many other processors available. You can take them and you can try it on different processor, different systems as well. Fine. So this is what happening exactly in the back when we try to do these kind of scenarios. So but Java is somewhat different. That's where Java differs with respect to C. So how the Java differs with respect to C and all, let's try to see and try to understand in detail. So like first I want to take one Intel processor again, Intel processor system. So what am I doing is I am trying to create one small same kind of A plus B program and adding two numbers in Java as well. So I'm renaming this file as add.java. Alright, I'm renaming this file as add.java. So when I try to compile this program, I'll give this program to a Java compiler, right? I'll give this program to Java compiler. So immediately the Java compiler, what it will do is it will generate a dot class file. So likewise in C programming, in Java also the Java compiler will produce one dot class file. Like it's somewhat different from C. C it will produce .exe file, but in Java it will produce dot class file. Alright, it will produce dot class file. So we are doing it as a add dot class. Alright, it will produce add dot class file. So in this class file, this way differs between C and Java. Okay, try to understand, try to concentrate more. Alright, so here what it will have is J add 10,20. That means what it will have is the instructions that is specific to Java itself. That's where Java differs. That is, we'll try to understand in a moment. Concentrate more. Okay, so other than C, Java is having one more different kind of approach that is called as JVM. He is a hero in entire Java programming language. We are going to understand this in further classes in detail about the JVM, what is a JVM and what are the differences, like what is the difference between C and JVM, like what is the different approach JVM has followed other than C, and all those things. We'll come back and discuss about JVM architecture as well. So but for the time being, try to understand that JVM is the one which will try to execute our program other than Intel processor. So what is happening is immediately when I try to pass this dot class file to JVM, the JVM will convert the dot class to processor specific instructions code byte. So what will happen here is the JVM will produce processor specific instructions and then it will be executed and we can see the output 30, because Intel processor can understand I add instructions, right? So it will try to execute and we can see the output 30. So in the same way we'll try to take the other example, the scenario AMD processor. So now we are taking an AMD processor and we are trying to repeat the same steps and we are trying to compare and we are trying to learn what is happening in the back. So immediately when I try to create the same program again called as add.java in AMD processor and we are trying to give it to the Java compiler. So immediately when the Java compiler sees this program, it will validate the program and immediately it will try to generate one dot class file for us, right, with Java specific instructions. Alright, JVM specific instructions. So the JVM can understand these instructions and it will try to convert this to processor specific instructions. Immediately it will convert to processor specific instructions, that is called as add 10,20, right? Processor specific instructions. So immediately whenever the AMD processor sees this processor specific instructions A add 10,20, it can understand its language, it can understand this language or instruction, it will try to execute, and we can see the program output 30. So this is what happening with respect to Java, with respect to C. The same thing is happening, nothing other than, right? So now we'll try to take the reverse scenario and we'll try to understand why Java is better than C and how far Java is advantageous than C, right? So now what I want to do is I want to take Intel processor system again, and in this time I want to take this add.class which is generated in AMD processor. Are you getting right? I'm taking the .class file just being generated in AMD processor. So in AMD processor also we'll have the same J add 10,20, right? So the same the same J add 10,20 will be available in Intel processor as well as in AMD processor, right? So when you try to execute this, first JVM will take this and JVM will produce this processor specific instructions, right? JVM, what is the duty of JVM? It will always produce the processor specific instructions, right? So because when you try to install Java, JVM will present in every system, right? JVM will be present in every system, right? So immediately it will produce a processor specific instructions. So the Intel processor can understand this language and can understand this instruction, and it will try to show the output 30. So this scenario is a straightforward scenario, and it can execute where this scenario cannot be executable in C programming language. Alright, so in the same way we can take the other scenario, AMD processor, and we can take this .class file that has been generated in Intel processor. Alright, that has been generated in Intel processor. It will also have the same J add instructions, right? That is specific to JVM. So the JVM will again try to execute and show, execute and try to produce this AMD processor specific instructions. Alright, AMD processor specific instructions. So immediately whenever the AMD processor sees this one, it will try to execute, and we can see the output 30. So here what we are trying to understand is Java is platform independent. Alright. So what is platform independent? Platform independent means here in this case our Java program can be executable on different processors. The same Java program .class file can be executable on different processors. That is called as platform independent. But when you consider the other scenario, the C programming language, which is not executable on different processors, right? If you want to execute on different processors, we need to rewrite the program, and we need to recompile the program, and we need to re-execute the program. Then only we can see the output on different processors. So that's where C programming will be called as platform dependent, and whereas Java is called as platform independent. Alright, so this is all about platform dependency and platform independency. Alright, let's summarize what we have discussed till now, and we try to see some conclusions based on that. Okay. Yeah, let me start the server first. This is Tomcat server Apache. Don't worry how to work with the servers and all. We'll come back and discuss when we're discussing about servlets, JDBC and JSPs, right? So my server is started. Yeah, let me start the application. So actually I developed one small web application. Based on that we'll try to understand, we'll try to learn something. Okay, Java tuts. Yeah, so until now what I understand is like what is a program. Program is one which registers the task performed by the human beings. And how to run the program? Yes, it is the responsibility of the processor to execute the program. So then what is a processor? A processor is one which runs based on the instructions given to it. So not only Intel and AMD, there are so many other processors. You can take the AMD processor, you can take the IBM processor as well. For the example, if you want, I can see the same scenario, and you can take different two systems like Intel and IBM, and you can run the same kind of example if you want, right? So then comes what is platform dependent and platform independent. If a program can be run on single processor, then it is called as platform dependency. If a program can be run on multiple systems, multiple processors, then it is called as platform independency. Our Java is platform independent and our C is platform dependent. So now let's see the same small example in complete picture in single slide. Yeah. So C program. So here what we have done is we have tried to develop the same kind of a small application, that is adding of numbers, and then we are given to compiler, C compiler. The C compiler is giving .exe file, and we are giving the same .exe file to two different systems which are having AMD and Intel processors. So here the same Intel processor has been compiled, right? That's the reason why we are getting output, and we can see the output in this Intel system because it is also an Intel processor system. So but when we try to execute the same .exe file on AMD processor, we are not able to see the output because of its instruction that is understandable by Intel processor. Alright, so this is the reason why people call C as a platform dependent language. And if you want to run on AMD processor, again we need to create new program on AMD system like this, and we need to compile and we need to execute like this scenario. Then it is only the possible way to see the output on AMD processor, right? So that's the reason why people call it C platform dependency. So now if we take the same kind of example on Java, here Java, what the Java is doing, we are creating some same kind of program, add.java, and we are giving it to Java compiler, and the Java compiler is giving us .class file, and we are giving the same .class file to two different systems which are having, one is AMD processor and the other one is Intel processor. So here this time we already discussed that JVM will be present on every system when you try to install Java. So this time JVM will take that .class file and will generate a processor specific instructions which can be understandable by Intel processor. In the same way it will produce processor specific instructions which will be understandable by AMD. So now we can see the output on both the systems because here JVM is the one which is producing the process specific instructions other than the compiler, right? So that's where Java differs. That's the beauty of Java. That's why people call Java is platform independent. It can be run on multiple processors, right? So now let's summarize again based on the performance what is and all. Okay, so here comes the performance. So for the C we are having 4 steps of flow, but for the Java we are having 5 steps of flow. So what is those steps? Here we are developing the program, we are compiling, and then we are getting the .exe file, and then we are starting the execution. We are executing the program, and then we can see the output. But here we need to develop the program, we need to compile the program, it will generate .class file, then again we need to give it to JVM. JVM will be the process specific instructions, and then we can execute the program on different processors, then we can see the output. So here Java is having 5 steps of flow, C is having 4 steps of flow. That's the reason why the performance of C is somewhat high when compared to Java. But no doubt both the programming languages are having high performance, but C is somewhat high when compared to Java. But C is lacking of one more beautiful feature called as a platform independent, whereas Java is having platform independent nature. This is the only reason why in today's world people are pretty much interested in using Java programming language in developing any project. Even client also interested because of in order to avoid this platform independent or dependent problems. So like if you want to develop a project in India and you want to deliver that in USA or any foreign location, you might have or you might face some kind of platform dependent problems with respect to C if you develop that. So if you develop in Java, you don't face such kind of problems because Java is platform independent, right? So that's all for this session. I hope you like this video. If at all you like the video, you can share with your friends over there, and you can share the knowledge with them as well. So you can contact me, you can feel free to contact me on the following any of the links through my Skype or my Gmail ID. Thanks for listening to this video session. This is Roshan Kachinna signing off.